This is exercise 11.4 question 6, and it says prove that triangle LMN, in other words the big triangle, is similar to triangle YMX. Now, so prove that the big one is similar to this little one here. There's one triangle within another. Girls, can you see, look at the big one, look at this one. Can you see a common angle between the two of them? Yeah, angle M is common. So I'd mark that in with a different colour. So before I start, that angle, I should do it a double or something. That one there is common to both of them. Sorry, that's a funny marking. But what I'm going to do now, girls, I'm going to draw the two triangles separately. So I've got this angle here. I've got LMN. And I know that that's 40. This is 32. I don't know that distance, right? That's the big triangle. And the small triangle is this other one. It's MYX. I know that this is 30, this is 21, and that's 24. Look, I could have used a few different proofs for this, but I could do equiangular, girls, but I could have done another proof as well. So, you know, now that I've drawn these two separately, but, you know, I know that this one up here equals that one there. Now, equiangular is a far easier proof to write out. It's quick, all right? But what other proof do you think I could have looked at? Because here's my angle, and the other proof could have been showing that the ratio of these were, I could have done ratios. I could have gone, but you've got to match the sides. But I think we'll do equiangular, all right? Equiangular is so much easier. The other proof you could have done was I've got this angle. Tell me which side the 24 matches with, but girls. Yeah, 24 is between arc and pink dot. 24 matches with 32. So the other way you could have done the proof was go 24 over 32 and simplify that. And I think you get 3/4. They're both, and the 30 matches with the 40, and 30 over 40 is 3/4 as well. You could have proven it like that. But because always look for common angle, we can do this equiangular. The easiest proof here to do would be the equiangular proof. So I'm going to go in triangle LMN and triangle YMX. I start in triangle LMN and triangle YMX. What do I know? Girls, what do I know? The black ones. Angle MLN is equal to angle. This one equals MYX. Y. It's given. It was marked in. Okay? So we've got one angle. The other one that we saw, and we've drawn them separately, whenever they're overlapping, draw them separately, was that the pink ones are equal because they're a common angle. So angle LMN is equal to angle YMX. Reason, it's a common angle. I'll just go common. There we go. It's enough. You don't have to do the third angle. You don't have to say, well, the angle at N here equals the other one by angle sum of a triangle. You don't have to do that. So therefore, someone asked, can you do angle M is common? You can, just in this case. But girls, you need to, you would never be allowed to say angle Y because there's many angles at Y. There is only the one angle at M, but it is good to try and give the three-letter name. All right, so therefore, triangle LMN is similar. LMN is arc pink dot blank, similar to YMX. The reason is equiangular. Okay? That first. So MN over its matching partner. Its matching partner is MX. And you need to put the letters. Just don't go MN over 21. So I want MN over MX equals, all right, you're going to pick a pair. We've got lots of pairs. I need a full pair now. Yeah, So I'm going from this way. That length over that equals, let's do this one, ML over, what does ML match with? Over MY. Reason, corresponding or matching, corresponding sides of similar triangles in, do you want to write in proportion or the same ratio? In proportion. So now we substitute the values. So MN over 21 equals 32 over 24. You know what I didn't do here and what I should do to make it easier, because I'm finding it hard. Girls, I should be, circling, make it visual. They're a match. Do you know what I mean? So much easier. And this is a match with that. Don't forget to do that. It just makes your life so much easier. We know that that and that are a match, but I forgot to circle them and highlight them and whatever. When you do that, it's so much easier. So MN over 21, got it, equals 32 over 24. But please, when you find your corresponding sides, circle them, just like we did the colours with the angles. It makes it so much easier. So therefore, MN is, what do I do? 32 over 24 times 21, which is? Great. Now we have to work out, we have to find YN. N is 28. We know that MY is 24, so YN must be 4, because 24 plus 4 makes 28. So YN is MN minus MY, which is 28 minus 24. See? It's MN minus MY. So it's 28 minus 24, which is 4. Show that triangle PQS, the small one, is similar to triangle RQP, the big one. Now, if you don't draw the two triangles separately, you're not going to see all the information that you've got. But before you separate them, again, look at which two triangles, the small one and the big one. You should mark in the common angle that there is. There is a common angle at Q. So I'd mark that in first and then draw them separately. So I'm going to draw them separately here. Otherwise, you're not going to see what you're supposed to be doing. So before you separate them, you need to draw in the common angle. Otherwise, you won't see it. And then you can draw them separately. Okay, so I've put in the marked angles. We need to put side lengths. So what's RQ?
12.
Good. And QP? And QS is 3. And QP is 6. Now see in this case how the 6's are the same? This is the reason why you need to be talking about sides when you do ratios later. You can't go whatever over 6 equals whatever over whatever. The examiner's going to say, which 6 is she talking about? Okay? So that's why we need to name the sides and all that sort of stuff later. So basically, we're trying to prove that these two triangles are congruent. See, now that now that we've drawn them separately, you can tell it's going to be the angle and the two sides about equal angle in proportion. But girls, be very careful here. 12 matches with what? That's right. The bigger side here matches with the bigger one there. 12 does not match with 3 and 6 with 6. The 12 is bigger than the 6. The 6 is bigger than the 3. The 12 matches with the 6, and this 6, which is the smaller one next to that angle, matches with 3. Now that you've done that, you should be able to just tell me in everyday language that this second triangle is how much smaller than the first one? It's half the size. All right, so when you do your ratio, you know how you do one side over the other? You're going to get a half, depending which way you decide to do your ratio, or you're going to get 2. Depends which way you do it. All right, so let's just work with part A. So that's the question. Now, part A, show that the triangles are similar. So in triangle PQS and triangle RQP, what have we got? let's do the angle. I'd rather you write what it is. Wait, sorry, I'm going to change these around because I've written them the wrong way round. Oh, that's okay. I've drawn them backwards to how I've written it. Do you know what I mean? And I'm going to get confused. So I should go RQP here, RQP. Do you know what I mean? And triangle PQS. I just know that I'm going to be putting, this one first, that one second. I don't want to get them the wrong way round. So RQP and triangle PQS. What do we got? You told me angle Q is common. So angle RQP equals angle SQP. I wouldn't worry about the order. Common angle. You just say common. What else? Now, what are you going to put over what? Well, the circles are matching. RQ over PQ or QP, doesn't matter, is what? They're matching, we already worked that out, remember we're doing ratios? 12 over 6, which is 2 over 1 or just 2, okay? So remember we had to circle those to know that they're matching. What else have we got? So look what I'm doing. I'm going this triangle to that one. Yep, QP over, is it QS, is it the matching one? Yeah, it is. QP double underline over QS, so 6 over 3 is 2 over 1. So great, we've got, therefore, can you see it? You've got the SAS of similarity, but we don't write that. We say, therefore, triangle RQP is similar to triangle PQS. Sides about equal angles are in proportion. Sides about, you know what sides about means? The sides surrounding that angle, basically. Sides about equal angles are in proportion. That's the SAS similarity statement, basically. It's the SAS of similarity. Sides about equal angles are in proportion. Hence, you have to prove that angle PSQ, so prove that this angle here equals angle RPQ. That's going to be easy. So prove that that equals RPQ is this one. What's it going to be? It's one line. They're matching or corresponding sides of similar triangles. You know, once you've proved they're similar, always the angles are the same in similar figures or similar triangles. So we've proved that they're similar. So I know that these pink angles are the same. Look where the dot here is. It's opposite the circle 12. The dot here is opposite the circle 6. So the dots are corresponding angles as well. And you know this blank down here at R, it corresponds with this blank down at P. Remember, in similar figures, the three angles are the same, but the sides are in proportion. So therefore, hence prove that. So you can just say, therefore, angle PSQ equals angle RPQ. So we're moving up to part B. Reason, corresponding or matching. Corresponding sides of similar triangles. Angles, sorry, corresponding angles of similar triangles. Not in proportion, they're corresponding angles. The angles are always the same in similar triangles. So corresponding angles of similar triangles.